This question is from GATE 2015 Mechanical Engineering paper set 2, question number 52. A single point cutting tool with 0-degree rake angle is used in an orthogonal machining process. At a cutting speed of 180 meter per minute, the thrust force is 490 Newton. If the coefficient of friction between the tool and the chip is 0.7, then the power consumption in kilowatt for the machining operation is dash. Now let's start by writing the given information. So it's given that rake angle alpha is 0 degree. The cutting speed, let's denote it by V, is 180 meter per minute. So we can convert this to meter per second, 180 by 60. That is 3 meter per second. Then the thrust force Ft is given as 490 Newton and the coefficient of friction mu is given as 0.7. Now for this given configuration, if we draw the merchant circle diagram, this is how it will look. So if this is the cutting tool, it's at 0 degree rake angle. So here with the vertical, the tool is making a 0 degree angle. That's the rake angle. The forces can be then denoted as, so this is the cutting force in the cutting direction, cutting force. This is the thrust force. Opposite to the cutting force is the normal reaction and this is the friction force. So from this merchant circle diagram, we can see that the vectors Fc and N are equal in magnitude. Cutting force is equal to the normal reaction and similarly thrust force is equal to the friction force. So Ft is equal to F. We also know the relationship. Friction force is always equal to coefficient of friction into the normal reaction. So replacing these values here, we have in place of F we'll write Ft is equal to nu into N is equal to Fc cutting force. Now Ft is given to us 490. We need to calculate power consumption. So we'll calculate the cutting force first and whatever is the cutting force into the speed, into the cutting speed will give us the power consumption. Power consumption is nothing but force into velocity. So let's find out the cutting force first. From here we will have the cutting force Fc as Ft upon nu, which is equal to 490 upon 0.7. This turns out to be 700 Newton. And therefore we have the power consumption is equal to cutting force into the cutting speed, which is equal to 700 into cutting speed is 3 meter per second, which is equal to 7 3s are 2100, and the unit will be, force unit is Newton and velocity's unit is meter per second. So the SI unit of power, which is watt, is the unit here. But we have to write the answer in kilowatt. So let's just divide this by 1000. We get this as 2.1 kilowatt. Let's go back and fill in the answer. So the power consumption for the machining operation with the given configuration for the cutting tool is 2.1 kilowatt. To learn more about cutting tools, you can refer to the NPTEL video lecture 4 cutting tools from the course Introduction to Machining and Machining Fluids. This course is by Dr. Mamilla Ravishankar. He is from Department of Mechanical Engineering of IIT Guwahati. I hope this solution will help you clear your doubt. Thank you.